Chapter 4, Carbon and its compounds. So, before we study carbon and its compounds, let us do a simple activity. Select some material at home and make a table and find out which substances are made of metals, which objects are made of metals, and what are the things which are made of glass and clay, and the things which are neither made of metals nor of glass and clay, and select about 10 things in each column and segregate them. You will find that suppose you happen to see keys, doors, grills and so on, vase, plates, glass. Now, which things which are neither made of metals nor of glass or clay may be like food, cloth, paper and so on. So many things you will see that are neither made of this and nor this. Now, these things are made from the living substances. All living structures are carbon based. The substances generally which are obtained from the living things are made up of carbon compounds. Earth crust has about 0.02% of carbon in the form of compounds as carbonates, hydrogen carbonates, coal, petroleum. Also carbon is found in the free state also as diamond and graphite in the nature. In the atmosphere, carbon dioxide is present as 0.03%. Now, to study further about the carbon compounds, let us study about the melting points and the boiling points of the carbon compounds. Some of the carbon compounds like acetic acid used in daily life as vinegar, CH3COOH, these melting points and the boiling points are in Kelvin scale, 290 Kelvin and 391 Kelvin. Alcohol, C2H5OH, and it is also called ethanol, has melting point 209 and boiling point is 334. Chloroform, formula is CHCl3 and its melting point is 156 Kelvin and boiling point is 351 Kelvin. Methane, formula is CH4, melting point 90 Kelvin and boiling point 111 Kelvin. Okay. Now, you have seen that these carbon compounds have low melting points and boiling points. You have studied about the ionic compounds in the previous chapter. Ionic compounds have very high melting points and boiling points, but the carbon compounds have very low melting points and the boiling points. So, they are different from the ionic compounds. Also, you have studied that ionic compounds are very good conductors of electricity because of the presence of ions, which help in conduction of the electricity. But the carbon compounds are non-conductors of electricity. That is, they are not made up of ions, they are made up of molecules. So, by studying and comparing the properties of ionic compounds with carbon compounds, there is some different type of bonding in carbon compounds. Let us study first of all the electronic configuration of carbon. As you know, atomic number of carbon is 6, that is, it has carbon atom has 6 protons and so it has 6 electrons also, and its electronic configuration is 2, 4. Now, as we studied earlier that elements react in order to attain inert gas or noble gas configuration. So, in this particular case, to attain the nearest noble gas configuration, it should have 4 more electrons. Neon gas has got the configuration 2,8, it is an inert gas, noble gas. So, to attain the neon gas configuration, it should have 4 more electrons. It should gain 4 electrons or it should lose 4 electrons to attain helium gas configuration, completing having duplet in the first and the only shell. Now, if carbon atom has to gain 4 more electrons, it will form C4 minus ion by gaining 4 electrons. So, the number of electrons will become 10, but number of protons will be 6 only. So, it will be difficult to hold on to 10 electrons, 6 protons holding on to 10 electrons. Now, to lose 4 electrons, it will form C4 plus 4 positive charge. Ion will form by losing 4 electrons. First of all, it is not at all easy to lose 4 electrons. A lot of energy will be required to lose 4 electrons to attain helium gas configuration. And also, it will be impossible to for 6 protons to hold on to less number 2 electrons only. 6 protons and 2 electrons. So, carbon atom cannot react either by gaining 4 electrons or by losing 4 electrons. So, what type of bonding is present in the carbon compounds? Carbon atom can form the bond by sharing of electrons, by forming covalent bond. Covalent bond carbon compounds form. So, first of all, let us study about covalent bond. Covalent bond is the bond formed by the sharing of electrons between the 2 atoms. So, let us study about the covalent bond in detail. So, now let us discuss about the different types of covalent bond. There are 3 types. First is single covalent bond. Single covalent bond is formed by sharing of 1 electron pair between the 2 atoms. Let us take the example of hydrogen molecule H2. As you know, the atomic number of hydrogen is 1 and it has got 1 proton and 1 electron. So, H2 molecule is formed by sharing of 1 electron pair between the 2 atoms. So, this electron pair is shared by both the hydrogen atoms. So, such a bond, such a covalent bond is called single covalent bond, and it can be represented also by making a single line between the 2 atoms. Single line indicates that there is a single covalent bond between the 2 hydrogen atoms. The second type is double covalent bond, which is formed by sharing of 2 electron pairs between the 2 atoms. Now, as example, we will take the case of oxygen. The atomic number of oxygen is 8. So, number of protons is 8 and number of electrons is also 8. How many valency electrons it has? It has 6 valency electrons. So, to attain inert gas configuration, it needs 2 more electrons and it completes its octet by sharing of 2 electron pairs. So, now let us make the electron dot structure of oxygen atom. So, we will make 6 dots outside each oxygen atom. So, you can see the each oxygen atom has now how many electrons? 4 plus 2 6 plus 2 8. The second oxygen atom also has 2 plus 2 plus 4 8 electrons in the outermost shell. So, both oxygen atoms have completed their octet by sharing of 2 electron pairs. And double covalent bond can be represented by making 2 lines between the 2 oxygen atoms. The third type is triple covalent bond. It is formed by sharing of 3 electron pairs between the 2 atoms. We will take the example of nitrogen. The atomic number of nitrogen is 7. So, how many protons in nitrogen atom? 7. And how many electrons? 7. How many valency electrons? 5. 5 electrons in the outermost shell. How many electrons does it need to complete its octet? Obvious answer is 3 electrons. So, each nitrogen atom shares 3 electron pairs to complete the octet. So, octet of one nitrogen atom is completed and the octet of other nitrogen atom is also completed. Triple covalent bond can be represented by making 3 lines between the 2 atoms. This shows that there is a triple covalent bond between the 2 nitrogen atoms. Let us draw the electron dot structure of some more compounds to show the covalent bonding between them, like ammonia. To make the electron dot structure, first of all we will make the electron dot structure of nitrogen. Nitrogen atom has 5 valency electrons and hydrogen atom has only 1 electron in the first shell. So, let us denote the electron of hydrogen as X, just to differentiate, as a cross. So, you can see by sharing 1 electron pair, all the hydrogen atoms complete their duplet and nitrogen atom also completes its octet. Another case of methane, in which the atomic number of carbon is 6. So, how many valency electrons? 4. 4 electrons in the outermost shell, and in the same manner hydrogen has 1 electron in the outermost shell, that is the first shell. Just for differentiation, let us make a cross for the electron of hydrogen. Each hydrogen atom has completed its duplet and also carbon atom has completed its octet. Carbon occurs in the nature in the free state also as diamond and graphite. Diamond and graphite are the allotropes of carbon. What are allotropes of carbon? I had discussed in the previous chapter also. Allotropes are different physical forms of the same element with different physical properties, but similar chemical properties. So, diamond, graphite, and another is fullerenes. These are all different forms of carbon. Diamond, graphite and fullerene, when they are burnt, they will form only carbon dioxide gas. As you know, they have physical different properties. Diamond is very hard, the hardest substance known. Each carbon atom is linked to 4 different carbon atoms by strong covalent bonds. Let us say this is a carbon atom. This dot indicates one carbon atom, second carbon atom, third carbon atom. So, you can see one carbon atom is linked to 4 other carbon atoms by strong covalent bonds. Covalent bond, and it forms a very rigid 3-dimensional structure. There is no free electron or there is no charged particle, charged ion in diamond. So, diamond is a non-conductor of electricity, it does not conduct the electric current. It is the hardest substance, as I have already told you, because of the strong covalent bonds. Diamond can be prepared by, in the lab it can be synthesized by heating carbon to a very high temperature and under very high pressure. Synthetic diamonds are little bit small in size, but otherwise we cannot distinguish between the natural diamonds and the synthetic diamonds. Now, this is very bright in color, diamond is very bright in color. When light falls on it, it disperses the light. On the other hand, the other allotrope of carbon is graphite, which is greyish black in color, and it is soft, slippery in touch. So, physical properties are totally different than diamond, and graphite is also a good conductor of electricity. Let us see why graphite is a good conductor of electricity. In graphite, each carbon atom is linked to 3 other carbon atoms, and it forms hexagonal layers like this. So, it forms hexagonal layers which lie one over another as we stack sheets of paper one over another. Like this. And these sheets of paper, they are loosely stacked over one another and are bound by weak van der Waals forces of attraction, and these are covalent bonds. So, each carbon atom is linked to 3 other carbon atoms by covalent bonds, and it forms hexagonal sheets, and these hexagonal layers are bound by weak van der Waals forces of attraction. So, these layers can slip over one another and are soft. Because one electron is free, that is why graphite is a good conductor of electricity. Graphite also has a high melting point. It is used as a lubricant for the machine parts which work at a very high temperature. It is used as a lubricant in as a dry graphite also, and in the form of a liquid also on mixing with petroleum jelly. And graphite we use for making lead pencils also on mixing it with clay. And also very important use of graphite is to make the electrode of the dry cells. If you see that black rod inside the dry cell which you use at home, that is made up of graphite, because it is a good conductor of electricity, so it is used to make the electrodes. About diamond also let us discuss some of the uses. One of the very important uses to make the jewelry, and also it is used for cutting the glass, and also used for doing the operations by eye surgeon to remove the cataract. The third allotrope of carbon is fullerene. Its formula you can see, it is C60. What does it mean? That 60 carbon atoms, about 60 carbon atoms, there are different types of fullerenes. One very important one is C60, in which 60 carbon atoms, they are bound to each other by strong bonds, covalent bonds, and it forms like this, a ball like structure. It forms various hexagons and pentagons. Different carbon atoms, they are bound to each other in the form of hexagons and pentagons and form a ball like structure. And it is named after because it looks like a ball, like a dome. It is named after a USA architect, Buckminster Fuller. So fullerenes is any other type of allotrope of carbon. Versatile nature of carbon. Now carbon has a unique ability to form a large number of carbon compounds by linking with other carbon atoms and also combining with the non-carbon atoms like oxygen, hydrogen, nitrogen. Now we will discuss about what is so unique about carbon. Carbon has the ability to link with other carbon atoms to form a long chain of carbon atoms, and this property is called catenation. Catenation is the ability of carbon atoms to link up with other carbon atoms to form long carbon chains. This is one of the ability, one of the unique property of carbon, due to which there are a large number of carbon compounds. Carbon compounds are of two types: saturated compounds and unsaturated compounds. Saturated compounds are those in which carbon atoms are linked to each other by single covalent bond, and unsaturated compounds are those in which carbon atoms are linked to each other by double or triple covalent bonds. There is no other element which forms long chains except silicon. Silicon forms compounds with the hydrogen, which have chains of silicon atoms up to 7 or 8 atoms. The silicon compounds are very unreactive, whereas carbon compounds are quite stable. And now another unique property of carbon is that carbon is tetravalent. It has 4 valency electrons, that is 4 electrons in the outermost shell, and its valency is also 4. So it can link up with 4 other atoms and form the bonds. Compounds of carbon are formed by combining with oxygen, hydrogen, nitrogen, sulfur, chlorine, etc. And the bonds which carbon forms are very strong and very stable. One of the reasons for forming the stable and strong bonds is that carbon is very small in size. If the bond is formed between the larger atoms, the bond formed will not be so strong. But in this particular case, because carbon is very small in size, the bonds which carbon forms with the other atoms are very strong. Now, earlier it was found that carbon compounds are found in the living beings only. Carbon forms a large number of compounds with so many other elements also, like it combines with hydrogen, nitrogen, oxygen, and it forms a large number of carbon compounds which are, earlier it was thought that carbon compounds can only be extracted from the living beings, and they were called organic compounds. But in the year 1828, Frederick Bohler synthesized an organic compound in the lab. He synthesized urea from ammonium cyanate, and then only it was found that organic compound can also be synthesized in the lab. But still, organic compounds are studied under a separate branch of chemistry, that is called organic chemistry. Only a few carbon compounds are studied in organic chemistry, like carbon dioxide, like carbonates, hydrogen carbonates, they are studied in inorganic chemistry. Otherwise, all other carbon compounds with hydrogen, oxygen, nitrogen, they are studied separately in organic chemistry.